Good afternoon, everyone, and welcome to this lecture. We are in lecture number 3, and we are dealing with electric field and electric potential. In the previous class, we had seen the relation between electric field and electric potential. We had seen how can we find out the value of electric field from looking at what we call as equipotential surface. We understood what are equipotential surface. Equipotential surface, a surface which have points of the same potential, and this electric field is always perpendicular to an equipotential surface. Do we remember this? Yes or no? And from this equipotential surface, we had also found out how we can calculate the value of electric field, the distance between the equipotential surface, the perpendicular distance. We divide the potential difference by the perpendicular distance, and we get the value of the electric field. Yes or no? In the last question, we had seen that we can find out the point between 2 points. We can find out the potential difference, and the potential difference between 2 points does not depend on path. So when we have to find out the potential difference between 2 points, you can go from point A to point B in any particular path. In any path that you go, the potential difference would be same. So which path you are going to choose? You are going to choose the path which has the easiest way to go. So you can move along the electric field, and you can move perpendicular to the field. When you move perpendicular to the field, there is no change in potential. When you move parallel to the field, potential decreases. If you move opposite to the field, potential increases. So we will write this important points here that will help you in solving question. Important points. We will try to summarize all the important points. So potential difference, PD, potential difference, does not depend on what? Can anyone repeat? Can anyone complete the sentence that I'm saying? Potential difference between 2 points does not depend on path. Well done, Abhiram. Potential difference between 2 points does not depend on path. Well done. The second point, perpendicular to electric field. If you are moving perpendicular to electric field, potential difference is 0, or you can say potential remains same. Do we understand this?
Yes, sir.
Potential remains same. Well done. Parallel to the electric field, potential increases. If you are moving in the same direction, potential increases, and you can say delta V will be equal to E multiplied by, I should not write it like this, E multiplied by R, distance. Yes or no? Do we understand this? Potential increases in the direction of field. Opposite. Oh, I've written it in the wrong way. Parallel to the direction of field, potential decreases. You go from higher potential to lower potential. So change in potential is minus E into R. Opposite to the direction of electric field, potential increases, and the change in potential is E into R. Can you remember this? We will do problems on this. I'll give you 2 minutes to note it down. Then we will deal with some problems here. Let me know once you are done, beta.
Completed, sir.
Boys? Boys are still noting, it seems. Okay, one more minute.
Completed, sir.
Completed, sir. Well done, sir. Then what we are going to do is we are going to solve some examples based on this, and that will help us in understanding the concept thoroughly. Okay. So let us go and solve some problem. And let me start with a problem. I could not find anyone in the thing, but I can make problems. So let us say this is an electric field which is going in the parallel direction. The value of the electric field is given as let us say 2 volt per meter. Let me ask the question in different ways. I have a point P, and let us say the potential of this point P is 1 volt. So I have some points in the electric field. The potential of point P is given as 1 volt. You know the positions of point Q, R, and S. This distance, oh, I forgot to give you this distance. This distance is given as 5 meters. And this distance is given as 3 meters. Or let me say 2 meters. I use everything. So now you have to tell me the potential of point Q, what is the potential of point Q, what is the potential of point R, and what is the potential of point S. You have 2 minutes to do this. Yes, bacha, anyone with an answer? Okay, I'll give you 2 minutes. Try. I know that you can do this. Everyone is trying, no?
Yes, sir.
Okay. Can you tell me the potential of point Q? If not anything else. What will be the potential of point Q?
1.
Potential of point Q is going to be 1 volt. Yes or no?
Yes, sir.
Why it is going to be 1 volt? Because it has to be same as the potential of point P. So you know one answer, and that is great. This is going to be 1 volt. It has to be same as the point P. Everyone understands this? So that is one part of the question I solved for you. I'm waiting for the other parts for you to solve. I'll give you 1 more minute to do this. Shall I do it? If you have given up, I can do it. Not a problem.
Sir,
Yes, beta.
R equals to 8.
RA equals to 8. The potential of point R is equal to 8. No, some small thing you have missed. Small thing you have missed. And that is why your answer is coming, which should not be coming.
2, sir.
Potential of point R is 2. How did you get 2? Whatever you say, there must be a logic behind it. May be correct, it may be wrong. But if there's a logic, then you can understand. If you are just saying the answer just for the sake of saying it, that will not help. But if you have a logic behind it, well, that is what I'm looking at. Okay. How do you get it? So we have to do it in the same way that we had done the previous question. Okay, where is my pen? Yes, here. Potential of point Q is 1 volt. Everyone understands this? Yes or no?
Yes, sir. Yes, sir.
Now look at Q and look at R. Which point will be at a higher potential, Q or R?
Q, sir.
Q will be at a higher potential. Q is higher, so I write VQ, potential of point Q. R is lower, so I write minus potential of point R. Now, how much should be the potential difference between Q and R? I can move straight along the electric field, along the pink line. What will be the potential difference between Q and R, my dear friends? What will be the potential difference VQ minus VR? It's a very simple question I'm asking. Yes.
-1, sir.
How did you get -1? How did you get -1? Anyone? What is the potential difference between Q and R? You've just noted down. I don't know where. What are you doing, beta? You just noted it down. What have you noted down? You noted down this. What have you noted down? What have you noted down? Okay. You might be getting confused with this. You just rub this thing off. Parallel to the field, potential decreases. You write it this, and opposite to the field, potential increases. How much is the change in potential? Yes. What will be the potential difference between point Q and R? How much is the potential difference between point Q and R? Electric field beta is given to you as 2 volt per meter, and you know the distance between Q and R is 4 meter. How did you get -1? How will you get the electric field is 2 volt per meter and the distance is 4 meters? So what is the potential difference between Q and R beta? We had done the same problem here, bacha. Do you remember this problem? This one? We had found out the potential difference between A and B. How did you find out potential difference between A and B? Do you remember this problem? Electric field was 2 volt per meter and the distance was 5 meter. You told me the answer of that potential difference, sir, is 10 volt. Do you remember this question, beta?
Yes, sir.
Thank God. So if you remember this question, then please bring that knowledge back here on this question. Between Q and R, what will be the potential difference between Q and R?
8, sir.
Why it's taking so long for you to tell me this answer? 8, sir. We know the potential of point Q is 1. 1 minus VR is equal to 8. So VR will become -7 volts. That is the answer for this one. Is it so difficult that you could not do it on your own? Okay, I'll give you 2 minutes to note it down. Let me know once you're done, beta. Because one part of the question still remains. Have you noted down?
Yes, sir.
Okay. Now we come to point S. Now, how will you find out the potential of point S? You can do it in many ways. I will tell you one of the ways. Originally I know the potential of this point is P is 1 volt. Now I have to go to point S. When you have to go to point S, you can choose your own way. You can go in any particular way. But what is a good way to go? You should move perpendicular and parallel. So that is how I'm going to go. First, I will go like this. Let us come to this point T. And then I will move like this. So this is how I will go. First, I move down and then I move like this. Now we know the potential of point P is 1 volt. Can you now tell me what is the potential of point T?
One volt, sir.
1 volt. Well done. Now look at T and look at S. Which point is at a higher potential, T or S?
T, sir.
So T is more, Abhiram, and S is less. What will be the potential difference between T and S? The value of electric field is 2 volt per meter. The distance between Q and S or T and S is 3 meters. What will be the potential difference between T and S? The potential difference between T and S would be this 3 multiplied by this 2.
5, sir.
So it will be equal to 6 volts. Vt minus Vs will be equal to 6 volt. Now Vt is 1 volt. We have already calculated. 1 minus Vs is equal to 6. So Vs will be equal to minus 5 volt. This is the answer that I was searching for. Is it so difficult for you to understand, beta? I hope you can do this in the next attempt. I'll give you 2 minutes. Take a deep breath. Open your eyes. Look at the question very, very carefully. I'll give you 2 minutes. I will keep my mouth shut. I'll keep the camera shut. Open your eyes. See the question. I'll give you one more in the time. And I hope that you can solve this one. Has everyone noted it down? Then this is the next question. Electric field is given as 5 volt from meter. Then there are some points. Potential of point A is given to you. Potential of point A is given to you as 5 volts. Rest distances are given. You have to find out the potential of point B, C, D, E, and F. If you understand this question, that means this topic is logged forever. You have 2 minutes to give me the answer. Yes, bacha. Anyone with any answer? Are we getting answers? Or shall I do it as usual? Shall I wait or shall I tell you how to do it? Shall I do it?
1 minute, sir.
Okay. Okay. I have patience. I have patience. Boys, everything is okay? Are we trying? Thank you.
Sir,
Yes.
there is a question 25.
Okay. Okay. Let us solve it together. Look at point A and look at point B. Which is at a higher potential, A or B?
B, sir.
B, sir. Well done, sir. So let us first write VB minus VA. How much will be VB minus VA? It will be 20 volts. Yes.
20, sir.
We already know the value of VA. VA is 5 volt. So your VB becomes the first voltage.
Sir, 25.
Well done. See, it is very simple. Once you get the value of VB as 25, this is an equipotential surface beta. So this will also be equal to 25 volt. This will also be equal to
25,
25 volt. Yes or no? Everything is
Yes, sir.
same. Equipotential surface. Well done. Now you can move ahead. Now look at this point D bacha and look at this point E bacha, which is at a higher potential, D or E?
D, sir.
D, sir. So I write dVd minus VE. How much would be VD minus VE?
15, sir.
15 volt. Well done. We already know the value of VD. From there, you will get the value of VE. How much is the value of VE you are getting?
10, sir.
10 volt. Now, you could find the potential of F from E, or I can find the potential of F from C also. Doesn't matter how I do. Now, we know that the potential of point C is 25 volt, and we also know, bacha, that this length will be equal to how much? This length will be equal to 1 meter. Yes or no? No or yes?
Yes, sir.
From there, you can find out, bacha, what is the potential difference between C and F. Who is at a higher potential? C or F? C is at a higher potential, so VC minus VF. How much would be VC minus VF?
5, sir.
5, sir. We already know the value of C is 25, sir. So the value of VF becomes 20, sir. Remember, one problem will come from this. If you understand this, one problem is locked. Everyone got this? Yes or no? No, yes.
Yes,
Yes,
sir.
sir.
Okay, I'll give you a minute if you want to. Note it down, note down, and how I have done it. Shall we move ahead in life? Have you noted it down?
Sir, done, sir.
Okay. Now, since we have understood
Sir,
how to find out the potential difference, the next thing and the last thing for this is how to find out the work
sir,
done. Yes, beta?
sir, one more question, sir.
You want one more question?
Yes, sir.
Okay. I will give you one more question. Electric field is given as 4 volt per meter. I have some points A, B, C, A, B, C, D, E, F, G. This is given as 5 meter. This is given as 4 meter. The potential of point A is given as 2 volt. Find out the potential of all the points. You have 2 minutes to solve it. Abhiram, your answer is not correct. Look at the sign also. Now correct.
Sir,
Beta.
sir, VB equal to minus 22.
Wrong, beta.
Sir,
Yes, beta.
the question again.
VB is equal to minus 18. Yes, that is correct. VB is minus 18.
Sir, VC, VD, VE equal to minus 18, sir.
Correct, sir. You just have to add and subtract. Do it correctly. Shall I do it? The rest of the points?
Sir, VF equal to 30.
How did you get 30? Okay, so let me solve it for you. This is point B, this is point A. Which point is at a higher potential?
A, sir.
A, sir. So higher potential VA minus lower potential VB. How much is VA minus VB?
20, sir.
20, sir. From here, you cannot find out the value of VB. It's a plus minus thing, yeah. VA is 2 volt. I will not even write it because I want you to do it on your own. So VB will come as
Minus 18, sir.
Pakka?
Yes, sir.
Okay. Take it. Happens sometimes, don't worry. Okay. As soon as you get the value of VB as minus 18 volt, this also becomes minus 18 volt. This also becomes minus 18 volt. And this also becomes minus 18 volt. Now, what is the next step? The next step is to find out whether which point is at a higher potential, G or D.
D, sir.
G, sir. That's it, sir. So you do that. VG higher minus VD lower should be equal to how much?
16, sir.
16, sir.
16, sir. Now you know VD is minus 18. So VG becomes
Plus 18.
This is minus 18. So minus minus becomes plus. It goes on the other side. VG becomes minus 2 volts, sir. Yes or no, sir?
Yes, sir.
Just have to do plus and minus, nothing else. Okay. Look at point F. Look at point E, which is at a higher potential, F. So potential of point F minus potential of point E should be equal to 3 multiplied by 4, 12. You know the potential of point E. I will write it for once. Minus 18 is equal to 12. So VF is going to
6.
come as minus
Minus 6.
volts. You got this, everyone?
Yes, sir.
Okay, so that takes us to the last part of this particular thing. Everyone understands this?
Yes, sir.
The last part of this is work done in moving a charge. Work done in moving a charge. Now, if you move a charge from point A to point B in an electrostatic field, work done. If you move this charge from point A to point B in any path, if I move a positive charge, work done in moving a charge from A to B by the electrostatic force will be equal to Q multiplied by VA minus VB. Do we understand this? So you find out the potential difference and you multiply the charge with the potential difference, that will be equal to your work done. Do we understand this?
Yes, sir.
Yes, sir.
What you have to remember is if potential difference is 0, that will imply work done will be 0. If a charge is moved, on an equipotential surface, if a charge is moved on an equipotential surface, in equipotential surface, if you move a charge, there is no change in potential, so the work done would be equal to 0. Do we understand this?
Yes, sir.
Everyone understands this? Yes or no, sir?
Yes,
Yes, sir.
I'll give you a question to log this topic. I'm expecting a question from this particular thing. So you have noted down this one?
done, sir.
This is the question. I'll give you 1 minute to solve it. Anyone got the answer? Anyone got the answer? Yes or no? No or yes? Eh? Anyone got the answer?
For 1 minute.
Okay. Okay, so what is the work done here? Anyone? Sir, point 1 is the correct answer. Work done is charge multiplied by the potential difference. Work done, my dear friend, is given as 2 joules, 2 joules, 2 joules, and the charge is given as 20 coulombs. So the potential difference would be 2 joules divided by 20 coulombs, and the answer for potential difference would be 0.1 volt. Do we understand this? Yes or no? No or yes? Boys, do we understand this?
Yes,
Huh?
sir. Yes, sir.
Yeah, sir. Okay, sir. Now, what you are going to draw is some equipotential surface. If you have a point charge will create spherical equipotential surface. So the spherical surface created by a point charge will be spherical. Do we understand this? All these are equipotential surfaces created by the point charge, and you can see this is the electric field line which is perpendicular to the equipotential surface. Everyone sees that? Yes or no? No, yes.
Yes, sir.
A point charge will create equipotential surface, also a spherical charge, sphere, uniformly charged sphere, uniform. If it is non-uniform, then it's different. Uniform spherical surface will also create spherical equipotential surface. Do we understand this? Yes or no? No, yes.
Yes, sir.
Yes, sir.
Ah, a line charge, a line charge, a line charge, a line charge will produce cylindrical equipotential surface like cylinder. Line charge produces cylindrical equipotential surface. Do we understand this? Yes or no? No, yes.
Yes, sir.
Yes, sir.
Okay, you just have to write this if you want. You want to draw this, you just have to write what type of equipotential surface are produced by what type of body. Don't have to draw it. You just have to write it. Do you understand what we are doing here?
Sir.
If you want, you can draw it. A uniform electric field. A uniform electric field will have plane equipotential surface. That is what we were doing questions on. Yes or no? No, yes.
Yes, sir.
Electric field is uniform. Equipotential surface are planar. Do we understand this? Huh?
Yes, sir.
So basically, we have seen three types of equipotential surface: spherical for point charge, also spherical charge; cylindrical for line charge;
Sir.
and plane for uniform charge. Do we understand this?
Sir, can you show previous slide?
This is the previous slide. For point charge, we have spherical equipotential surface. For line charge, we have cylindrical equipotential surface. And for uniform electric field, we have plane equipotential surface. Do we understand this?
Yes, sir.
So if I move any charge here, from here to here on this equipotential surface, what would be the work done? If I move a charge from here to here, what will be the work done? The work done would be equal to, if I move a charge on a equipotential surface, what will be the work done in this case? It will be equal to 0. Do we understand this? Yes or no?
Yes, sir.
Because there is no potential difference. We understand this?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
If you have a line charge and you move any charge on a cylindrical surface, the work done would be 0. Do we understand this? Yes or no? No, yes.
Yes, sir.
Yes, sir.
Say it loudly. And these are the two diagrams. You might not get a question on this, but these are the equipotential surface created by 2-point charges. Here you can see there are two positive charges. These are the electric field lines. We have drawn these electric field lines before. You draw the equipotential surface perpendicular to them and you get your equipotential surface. So just have a look. They might give you this diagram and they might ask you what type of equipotential surfaces are there. Do we understand this?
Yes, sir.
That's it from my end for today. What we have done is we have seen the various types of equipotential surface, and remember, electric field is perpendicular to the equipotential surface. Between any 2 points on the equipotential surface, the difference in potentials is 0, and therefore the work done is 0 if you have to move a charge on a equipotential surface. Everyone understands this? Yes or no? No, yes.
Yes, sir.
And remember how we can draw this equipotential surface. If you see electric field line, just draw perpendicular to that electric field line and you have equipotential surface in your hands, beta. So we have drawn the electric field lines of the charges. You just draw perpendicular to them and you have your equipotential surface. On that note, I will finish the class here. The next class we'll move probably with the new topic, which is electric dipole, and that is the last topic of electrostatics. So we'll be done with electrostatics in all probability by tomorrow, or maybe by Saturday. We'll be done with electrostatics and then we'll move on to capacitance. That would be the next one in line. Take care. God bless you all. Bye bye.
Thank you, sir. Bye, sir.
Bye,
Thank you,
sir.
sir.
Bye. Keep working hard.